Welcome everybody to this Qt on iOS session. My name is Richard. I've been working with Qt for about 7 years. For first and foremost on the Mac OS 10 port, implementing features, fixing bugs, but also on Qt Quick Controls for a couple of years, and mostly a little bit here and there, basically. Now I'm working on the iOS port, but I'm not doing that alone. Currently we are 2 developers working 100% on the iOS port, and then we have several other people helping out with various stuff, like we have one guy working with Qt Multimedia, making sure that we can play video and audio on iOS. Currently only supported for widgets, but soon for QML too. We have one guy sitting here in Berlin working with a Qt Creator integration, so you can sit in Creator all the time and click play and run your applications there. And then we have various other people helping out with the features and bug fixes every here and there. So this presentation will not be any slides or anything. I'll basically just code an QML2 application here on stage for you. So I mean, this is the point with a new platform port, is that it shouldn't really be a lot of stuff for you to think about that is special for iOS. It should really just be take your old Qt application, do qmake and make, and it should just work. But of course, the iOS port is not really ready yet. We are, it's going out for Qt 5.2, so currently it's a bit work in progress for us, which means that I need to do a little bit of manual plumbing right now to get it to work. And some of the reason for that is that Qt on iOS is built statically, which is something that is enforced on us by Apple, which means that it will take your application and bundle Qt and every plugins and everything into your application executable. So if, for example, go into your Qt folder, you'll see that there's not a bunch of frameworks there that you might expect from, for example, OS 10. Instead, there are a lot of .a files, .archives. This shouldn't really be any problems for you to think about. It's more problems for us. It's okay with normal C++ widgets applications, no problem. QML is a little bit differently. Since every QML file has some imports at the top, those imports are usually backed by some plugin somewhere, which means that if we are going to deploy this application onto the device, we need to find out which imports are you depending on, find the plugins, and link them into your application at build time. We need to find the resources those plugins depend on, so forth. And we have tooling support for that right now, but it's a little bit immature at this point. So that's why my code looks a little bit more complicated than it needs to be for 5.2. Okay, so what I'll do is that I'll create a QML application, as said, and I'll focus a little bit on the new APIs in Qt for dealing with mobile development, like working with orientation, working with sensors, handling the state of your application. So that will sort of be the first half of this presentation. And the second half, I will show you how you can mix in the usage of native APIs on iOS together with your QML application. So I'll just basically continue to extend the same example all the way to the end. Okay, so basically I've created this little boilerplate application to start with, so I don't have to type everything from start here. So let's just open it up and take a look at it. So this is the main.qml file where I'll do most of the work. It's a very simple, small file so far. I have a set of imports here. I'm going to work with Qt 2, of course, and some orientation stuff. That's a part of Qt window. And sensors I'm also going to show. And then I have a little main.cpp file that basically is just creating a Qt view that points to my main file and show it. But then we have this little section of code here that I was talking about, this little manual plumbing. So now I know that I'm going to use 3 modules. I know that those depend on 3 plugins. So I had to do this QImport plugin and stuff myself at this point. This is going away for Qt 5.2, so you don't need to really understand this at this point. The same with this little line here. Okay. I also have some code here in case I screw things up, so I can just copy and paste. So let's start by looking at this example. I'll extend it a little bit already now. I already have a little icon here, a Qt.png, a little logo. So I'll start by just showing this logo actually, like this. And of course, when the Qt Creator integration is done, I will be able to just go down here and click play. But it's not really mature enough right now. It was supposed to be ready about last week, I think. It will most likely be ready for Qt 5.2. Okay, so I jump into my little project here and type qmake. And what you'll see that we will create a little Xcode project for you if you do that. And I mean, we will always do that, even when the Qt Creator integration is done. We will always create an Xcode project for you, which means that at any point in time, if you like, you can always jump into Xcode and do the development there instead if you want to, or if there's something in Xcode that you need to do that you cannot do from Creator, for example. You go into Xcode instead. So let's open up this Xcode project. And let's use a simulator target right now. I just click play. That sometimes happens. Okay, so that was a very big simulator. My first Qt 2 application. If I now rotate this simulator, you'll see that auto rotation is on right now. So that'll be my first goal for this presentation, is to switch off auto rotation and do the rotation from QML instead. And how would I do that? Now for Qt 5.2, there's been some discussion back and forth on how to deal with rotation, auto rotation, and orientation. And the more we dig into this, the more we realize that there are many corner cases and tricky things to solve. So we decided to sort of defer it a little bit until Qt 5.3 to sort of look at the whole chain, from the runtime APIs to how do we set up the configuration files. Info.pl is typically on iOS, manifest on Android for dealing with this. But right now, to switch off orientation, you just go into Xcode and you find this little supported interface section down here. Then just click, I want to lock it to portrait, and run it again. So now it's locked to portrait. Okay, so let's go back to Creator and make this little image rotate instead. So just set rotation on the image. And now there's an attached property, screen attached property, that you can use to query the orientation. What is the actual orientation? And this orientation is the actual physical orientation of the iPad in this case, not to be confused with the interface orientation, which is what we actually switched off from Xcode right now. So interface orientation is what happens when you actually auto-rotate the content. Then you change interface orientation. So screen.orientation will always be the physical orientation of the device, and this will always change. So what I say that if screen.orientation equals Qt.portrait orientation, well, then I don't have to do anything because my icon is already in portrait, or this application. Otherwise, I want to rotate it a little bit, 90 degrees. And to spice this example a little bit more up, I'll add a little behavior here. Oops. Behavior on rotation. I'll create a little number animation. That should last for a second. And then I say that the easing type should be easing.outBounce. So I had a little bounce state. So when I rotate the iPad, it'll sort of bounce a little bit. Okay. Let's go back to Xcode and run it again. There we go. So it's pretty simple to do that from QML if you want to do that. Okay. So let's extend this example a little more. So what I want to do is I want to make this image bounce a little around on the screen. If I tilt the iPad like this, I want to make the image roll around like a ball on the iPad. So how would I do that? Well, then you have to make use of Qt sensors. And the Qt sensor module is fully available with on iOS. Just search up the compatibility map. Documentation from Qt sensors. These are all the sensors available in the module, and this column shows you which sensors are available on iOS. So you have the accelerometer that gives you measures the gravity in 3 directions towards Earth, and you have the compass that gives you your heading towards geographical north or magnetic north. You have the gyroscope showing you rapid movement of your device. The magnetometer showing you raw magnetic fields nearby your device, including, of course, the Earth's own magnetic field. And then you have the proximity sensors that tells you if you hold your iPhone close to your ear or not, in which case you should, of course, switch off all your CPU-intensive graphical stuff, because the user is not going to see anything anyway. So now I'm going to use the accelerometer to find the gravity. So let's go back here, and it's pretty simple. Just I want to use the accelerometer. I can do that since I already did the import Qt sensors up here. A sensor is not on by default since it consumes a little bit of battery, so you need to sort of switch it on or say when it should be on. I'll switch it on now, always. And each sensor has a property called reading that gives you the current reading of the sensor. So let's just start by printing out what the reading is. So I'll do like this. And see what we get. And the simulator does not have a sensor, so this time I need to switch to my little iPad here. Takes a little time to bundle the application and push it over to the device. Okay, so this is basically just the output. Just shows me raw readings from the sensor, which is of course a good start. That means we can start to do something fun with it. Okay. Let's go back to Qt Creator. I'll make this image bounce a little bit around, and I don't want to type all the code for doing that, so I'm going to go look at my little snippet here and add some properties and little function to it. Just copy that. And like this. I'll explain these properties in a little while here. Just give this little ID. Okay. So what I'm saying here is, okay, I give this image some extra properties, just some quasi-physics properties. Tell it that it will always have a speed in both x and y direction, and it should respond to certain friction, bounce, and gravity. Don't understand this. Need to understand this code. It's just my own mock-up for making something cool. And then I have this little function that I'll call whenever the reading from the sensor changes. Gives me the new reading. I'll calculate the new speed of the icon, move it a little bit around, and make sure that if it actually hits the wall in the screen here, it will bounce right back. So instead of printing anything right now, I'll just do image.move, like this. Go back into Xcode and run it again. Okay. Now, if you can see this all the way in the back. Yep. So it's pretty easy to start working with sensors. All the sensors are basically the same, so just as simple. And less than 60 lines of code, which is good. Okay, so that sort of was that part. With Qt 5.3, or really Qt 5.2, we introduced a new enumeration into Qt called application state. And this has now been extended in 5.3 to also be usable from QML side. So what it means that now QGUI application will have a new property called state that you can query at any point in time to find out what is the current state of your application. And from before, we just sent out a couple of events in Qt called application activate, application deactivate, which is far too limited when we work on mobile devices, Android or iOS. And besides, an application is active on desktop also means that it has keyboard focus, and that is not valid on iOS because Lineage should, for example, only have a blinking cursor if the virtual keyboard is up. So if you close the virtual keyboard, the focus should go away, but the application remains active. But that was sort of a hard requirement in Qt, so we came up with this new application state. So it's actually in Qt namespace. Jump directly into the header file. Call application state. Okay, so QGUI application now has a property that can contain any of these values here. Application active means that the application is the forefront application on the device, has the user's focus, basically being the main application. Application inactive. On the desktop, it means that if I, for example, show the simulator now in front of the creator will be now inactive. And active again. On iOS, you only have one application showing at a time, so an application will be inactive if you receive an incoming phone call, for example, or a message box pops in front, or you pull down the status bar, etc. It will become inactive. The third state, application hidden, means that the application has absolutely no visual pixels on screen at all. So if you have any graphical resources at this point, you should really remove them, delete them, free them up. This is a state for an application that typically runs as a daemon in the background, just playing music, for example. But this state remains to be implemented on iOS. The final state is application suspended, meaning that the application is about to suspend, actually stop executing code at all. So on iOS, this means that when you get into this state, you have 5 seconds before your application stops running. So at that point, you should save your state, free up release database connections, so forth, and you have 5 seconds to do that. And then the application stops executing, and at that point, you need to be prepared that your application can be killed at any point in time if the OS runs low on memory, for example. It will just go around and purge a suspended application and kill them. So the next time you actually execute code in your application, it might be from the start. Okay, so let's use this in our little application. So what we can do now is that there's really no reason for us to keep this sensor on all the time unless the application is actually active. So let's just do Qt.application state, which is the easy way to get the stateful application. I want my sensors to be active if Qt application state equals Qt application active. Okay, so now it's bouncing around. So if I drag down the status bar here now, the sensors should stop giving you data. So now the icon stops bouncing, and I know not everybody can see, but if you sort of, and it starts again. So it's easy to use and should be used. If I click to get back to the application launcher, it will now be suspended. It'll actually briefly enter inactive for half a second before it gets suspended. That's how it works on iOS. Okay, so that was sort of the first half of the presentation. The second half is mixing Qt with the native iOS APIs. And why do you want to do that? So there is no secret, of course, that there's always be new iPhones, new iPads. They will have new features, and it will always take some time before we can implement support for that on Qt. And I mean, sometimes it doesn't even make sense, right? If there's no cross-platform story behind it, if there's no equivalent behavior on Android, we'll probably not implement it in Qt just because it makes sense on iOS. That's one reason why you want to dig into the native APIs, or you really want to use some native control on iOS to use the latest and greatest, or you make your application look very native. That's also the point where you want to dig into the native APIs. Otherwise, of course, you don't have to do that. It's just something that we realize that is probably important for many iOS developers, and we want to really make an effort to making that easier or very easy to do. So it's at least that's on our roadmap for Qt 5.3, is to put some extra work into make that go smooth. Okay, so first thing you probably need to know when you mix Qt with iOS code is that Qt is of course C++, iOS is Objective-C. So which is fine, you can mix and match those two languages, but there are a couple of gotchas that you might fall into, and I'll run into one of them on purpose right now when doing this. So the application, what I want the application to do now is that I want to open up the native camera, the camera on the device, and I want to take a picture with it, and I want to bring that picture back into my QML scene and let that image bounce around instead. So the first thing I would like to do is to create a new item in Qt Quick from C++ side, so I can wrap in the Objective-C code that I'm going to write. So let's just start by doing that. New C++ class, call this iOS camera. And it should be a Qt Quick 2 item, since I'm going to use it from QML. And continue, sure. Okay. So this is my class. I'll add a little function called open to it that I can call from QML. Not a signal, it should be a slot. And let creator do its little thing here. Okay, and so that's it for now in this class, but I need to register it so I can make use of it from QML side. So I go into my CPP file again, and okay, and I need to register this as a new type. Just type iOS camera. Should have the namespace iOS camera. This is the first version, 1.0. And the item name should also be iOS camera. Is this really right now? Camera register type iOS camera. Okay, looks good. And then I can go back to my QML file and start using it. So first thing, I need to import it. iOS camera was what I was calling it from C++, 1.0. And name of the type, iOS camera. Camera. Okay, so what I want to do is that when this image bounces around on the screen, if I tap on it, I want the camera to open. So let's add a little mouse area to the icon. Anchors fill parent. On clicked. Camera open. And it auto-completes, which is a good sign. Okay, I touched many files here now. Save all. I'll do an extra QMake here since we added some new files. Into Xcode, clean project, and run it. Okay, so when I tap this icon now, it should just print open camera. It does. That's a good sign. Okay, so back into Creator, I'll open up the file where I'm going to add some. I'm going to add some Objective-C code in this function now for actually opening up the camera. So the first thing I would need to do is to include a main header on iOS for working with the interface, which is the UI kit. So this is the first problem of the evening, because if I go back into Xcode now and build, it will basically give me a lot of strange warnings and errors. It's like, I don't know what you're talking about. This alpha character here is completely unfamiliar. It says Clang. And the reason for that is that I'm actually building a .cpp file now, a C++ file. So Clang will refuse to build any Objective-C code if the file ends on .cpp. So the short story is just rename the file. This is sort of a hint to Clang that this is going to be Objective-C++. I could have renamed it just .m, which means Objective-C, but then you would have the reverse problem. Then it will start complaining about C++ constructs like namespaces or class, for example, which will be the case if you are working from Xcode and create a new file there. It will call them .m, so then you'll have those kind of warnings. So .mmm is the trick here. And since I changed the file, I'll just do a QMake here. Go back into Xcode, and now I do a build. And now it doesn't complain anymore. Okay, so then we can add in some Objective-C code. But of course, at this point, you will look up in the iOS APIs and you'll find out what you want to do. And so basically, you need to, those functions or classes in iOS are requesting certain handles that you need to sort of connect them with or call them with as arguments. So at this point, you sort of need to dig into the Qt application and get some handles to some native resources that you can combine with your native implementation. So what are you going to look for? So I had drawn some figures to explain a little bit on how Qt on iOS works. I'll use a storyboard, which is actually how you in Xcode would draw your user interface, but I'm abusing it a little bit now just as a drawing app for explanation. So this is a typical native iOS application. It consists of several view controllers, each presenting some part of the user interface to the user. And your UI application, native application, has one view controller, root view controller at a time that it shows to the user. So if the user, for example, clicks on button, you can say that, okay, please transition over to this next view controller that will show you something else. So they can, as an example, for example, stack on top of each other. And then when you're done with this view controller, you pop it off again, and then you go back to this first view controller here. So in your application, you typically have one UI window in the iOS application, or you actually have one UI window per screen. But since you only normally have an iPad or iPhone, you have one UI window. That UI window contains one root view controller that has a root view, and here you can add in all your custom UI views or UI button or all the controls you want to. So this is how a sort of a native application could be structured. A Qt application is very similar down here. So we also have one view controller. If you don't do any native development, you will only live with one view controller throughout the application lifetime, which is the QiOS view controller. So what happens is that when you create Q windows in your application, we will create a UI view behind the scenes and put it into this UI view controller here. That sort of will back up your Q window. So each Q window will have a UI view that backs it up, that we'll use for drawing OpenGL ES2 or raster or whatever into. And on iOS, we allow you to have more than one Q window, even though it's not recommended by Apple. But if you really want to, you can. This is mostly to support all the widget applications, so you can just take your old widget app and port it to iOS and run it if you want to. We don't stop you from doing that, even if Apple is telling you that you shouldn't. It's up to you. The main point here is that each Q window is backed by UI views. So the first thing you should probably do when starting this native development is to get the view that backs up your window. So in our application now, we'll grab the UI view that backs up our QML application. So let's go back into Creator and do that. Again, I'll cheat a little bit here from the little snippet. So down here, a little bit too far. I'll explain this code in a second. Okay, so the first thing we do is that there is a function in QGU application called Platform Native Interface that gives you an interface to communicate with the backend. And here I'm asking, please give me a native resource for this window here. And this window function is a function in QQuickItem, since this is a QQuickItem that gives you the QDeclarative window that this item lives inside. And QDeclarative window is a subclass of QWindow, so that's fine. So. Okay, please give me the UI view for this window, which returns a white pointer, so you cast it to a UI view pointer, like this. And to do that, you also need to do this little extra include here. Just Google it up if no reason to remember it right now. But once you have a pointer to the view, I mean, then you have sort of the entry point to the whole application. From the view, you can ask for the UI window, like I do here. And then you can ask for the root view controller, and then you can basically do anything, screw things up if you really want to, whatever. So what we are going to do now is that, okay, so now I have the Qt view controller, that is the controller currently active on screen. And then I say, okay, now I want to create a new controller called the UI image picker controller, which is a native controller on iOS for showing the camera and take a picture. So then I have some iOS code here for creating a new instance. If you don't know much about Objective-C, it's not that critical at this point. I'm not going to do so much Objective-C code, but this is how it looks like. I lock in it, it's all the same as new. And then I say I want to pick an image from the camera. I could also have said, please give me an image from the image folder on the device. And then this important little line here is saying, okay, from the Qt controller, please present this new UI image picker controller on top to let the user take the picture. And then later we'll pop it off. Okay. Okay, so now I click on the icon, it should just open up the new view controller. Yeah, the orientation was, I ran QMake and I lost some information there. That's okay. So then the camera opens up, and yeah, it's not easy to take something useful here. There you have a picture, and if I click use, it just go back. It pops off the view controller that I created and go back to the Qt application again. Yeah, sure. So like this, click on the image, opens up this controller, take a picture, and click use, and it goes back again. Okay, I'll click on this portrait again, say that we need to be in portrait here. So the final step, nice. Okay, that means I have some extra time. The final step is to get this image back into my QML scene. And I'm sure there are many ways of doing that, but I'm going to just show a very quick and easy way right now. So basically what I want to do is I want to take this image that I took, I want to save it to somewhere on the file system on the iPad. And then from the QML side, I'm going to use the image I already got and just point the source to this new image that I just saved. So a very common pattern on iOS for in UIKit for working with the controls, if you need to exchange information back and forth, you need to typically implement a delegate and assign the delegate, for example, to this UI image picker controller. And then this delegate of yours will be called back whenever the controller needs to talk with your custom code. So I'll create a new view controller, assign it to the UI image picker controller. Sorry, did I say view controller? Create a new delegate, assign it to the view controller, and my delegate will then be called when I've taken the picture. And at that point in time, I can save the image and do whatever I need to do. And that takes a little bit more code to do. So I'll actually cheat a little bit. I have a branch here already with that code. Just check out my camera branch. Xcode complaints because I wiped out the code underneath this feature. It's okay. Go back into Creator. So we basically this is exactly the same application as before. So this is the almost the only file that changed. So here is the old function open down here. Here's a new line I added where I'm setting a delegate here, something called my delegate member, which I create here up here in the constructor. So how does this delegate look like? This is how you would create a new class in Objective-C. You create an interface, and then you have an implementation for implementing that interface. This is the constructor. No need to understand exactly that part. This is the interesting stuff. This function did finish picking with media with info will be called when I say use the picture. Then it calls me and gives me a little dictionary here as argument. So the first thing I'll do is that I'll create a new path telling where I want to save this image. So then I'll say, okay, find directory, find the file path to the documents directory on the iPad, and append this little capture.png to the end of it, because this is going to be the file name of the image. Then I'm go ahead and save the image. First of all, I'm getting the image like this. This will be a UI image. And then I have this UI image PNG representation. This is all native code, nothing I have created. And I call this write to file. And then I give this path that I just created up here. So now it's saved down to the iPad. And then I have created a new property inside my iOS camera called image path. So what I'm doing now is that I'm pointing this image path, which is a QString, assign it a URL pointing to this new path. You have some conversion here. Just convert NSString to QString because path is an NSString here. And then we say now image path has changed. And this is sort of designed to QML that now you can do whatever you need to do. Now something has changed, so please update. And since I'm implementing a delegate here, I also need to say that please remove this image picker controller because now we're done with it. Go back to Qt's view controller again. Okay, so let's go into my main.qml code again. I have the camera down here, and now I say on image path changed, which means the user has taken a picture and clicked yes. Image path is now updated. And then I'll say that, okay, so I have this image here called emg. I say emg.source should now be image path. And this image will be quite big, so we cannot bounce around on the screen. So let's just make it a little bit smaller. Like this. Okay. Yeah, need to clean up the next code. Okay, so I click on it, it opens up the camera, and not the best motive, but do something. And I click use. Now it saves the image, and there it goes. Now it sort of bounces around on the iPad. Okay, so that is what I got for you. 10 minutes, I'm done. Any questions?
Yeah, it's pretty impressive. Thank you for that.
Mm-hmm.
And I've actually two questions. The first, can we rely that on Qt that we can put our applications to the App Store, so there's no private API call somewhere hidden and stuff like that?
Sure, absolutely.
Absolutely.
Otherwise,
okay.
it wouldn't be pointless to have it. So
Yeah.
we already have a couple of applications on App Store. You can search for sub attack. That's actually an old Qt application. That's in the Qt repository already for desktop that we have ported to iOS. Uses graphics view. And we also have Qt Quicksand. That is a Qt Quick 1 application.
Okay.
And we'll push another one, Qt Quick 2 application before 5.2 is out. So.
Okay, and my second short question is, I know that on iOS it is forbidden to use another WebKit port than the Apple one. So is it possible on Qt 5.2 to have a sort of web view?
Yeah.
Is it,
use the same approach that I show now to get the UI view. And once you have the UI view, you can add your own sub-views in as overlay over the Qt view as you want to. So then you can create an UI web view basically and add it as a child of the Qt view. But I have to say this is not something we have time to test so much for 5.2. This is what we are going to work more with for Qt 5.3.
But this is only working in the Q widget surrounding, not on the QML, or is it?
Yeah. It's from the platform plugins point of view, we don't care if it's QML2, QML1, or widgets running on top of us. We don't know that, so that'll just work.
Okay, so I can do it basically the same you did with the camera.
Yeah.
Okay.
But just I have not tested it myself, so it might be a little buggy. I don't know.
Okay.
I think it'll just work, to be honest.
Okay, I tried. Thank you.
Hello. I've got two questions about the libraries. How big is that application with all the static libraries linked? And if we can use just static libraries, how does that cope with LGPL?
Yeah. The application you saw right now, I will estimate to be about 16 megabytes, 16 approximately with Qt Quick 2. And shouldn't be all that much more. It's Qt Quick, sensors, GUI, yeah, about 16. And yeah, I'll keep it. I mean, we are planning to build for several architectures with different versions of ARM and stuff, and then you might need to actually have several architectures in one fat binary. Then it will increase the size of your application. But this application as it stands will be around 16 megs. And your second, oh, the LGPL. Yeah, I mean, that's a fuzzy area. That's some of the reason why we are coming with this new mobile edition, actually, so you don't have to think about it. I mean, people are a bit diverged on this matter, I would say. It's static linking is not something you normally can do with LGPL, but it's not entirely the truth. If I can keep it with that, I mean, you can provide object files or some way of linking your application. People have talked back and forth. I mean, I'm sure a lot of people here knows that answer better than me, to be honest. But that's why we have this new license, at least.
I've been playing around with Qt on iOS about, I don't know, 1 month ago, and the experience went very fine.
Nice.
Very great result. The only disappointment was with the way you are implementing the touch handling with the Q scroll area, which is far from being intuitive on iOS. For example, if you just want to, let's say, swipe in a scroll area, you have to use 2 fingers instead of 1. And I was wondering if it's something you intend to change in the near future. Do you see what I mean?
No, I didn't really understand the whole question.
The Q scroll area on iOS.
Scroll area.
Yeah.
For widgets.
Yeah, they behave, I would say, not very intuitively.
Yeah. I mean, widgets are something we are not working so much with anymore. But I mean, this is typical how we discuss things when we implement, because as a platform port, we don't really want to know that there are widgets running on top of us or QML running on top of us. So we think that this is something you need to fix up in widgets and not the iOS plugin per se. It's not really the problem there, but if this doesn't work, then we should definitely fix it. I mean, but we have no plans for doing that right now. That I can say.
It works, but it doesn't work as expected. I don't know if there are other guys who tried it, but
yeah.
On iOS, a scroll area just need basically 1 finger to scroll.
I mean, if it's
and here you need 2.
Yeah, I understand.
And it doesn't, you don't have the How do you call that? Yeah, exactly. Yeah, you don't have the exponential fading, for the curve. It's just like
Okay.
I was just wondering. No plans for that.
Yeah, okay. No. I mean, there might be many such similar issues right now.
Okay.
So yeah, we just need to. That will be normal maintenance bug fixing for us going forward to fix up stuff like that. So, but we really hope that most people will start using Qt Quick 2 instead of widgets. But we do support widgets fully for those that really want to do that. I mean, not everybody wants to push their app to App Store, and we understand people have different requirements.
Yeah, as far as I've seen, the QMake build step does some fancy stuff like adding this common runtime thingy, this object file for switching the entry point inside the application. Will you also have a good solution for having CMake as a build step?
We are
for the roadmap for 5.2?
Yeah. We are definitely keeping that in mind, not only CMake but also QBS, and we don't want to make this as a QMake only thingy, and that's also some of the reason why we haven't done. For example, we have patches that could fix up this orientation stuff that I was showing to lock orientation to portrait from QMake, for example. That's some of the reason why we said no. Let's just wait with this, because then it's a QMake thingy, and what about CMake? What about QBS? Perhaps we should create our own little manifest file that is cross-platform, that you can set up those things that translate to manifest on Android, InfoPlist on iOS, but we don't really have the time right now. That's why we have deferred this a little bit. But yeah, we think about CMake.
Hello, I'm here. Yeah, I have 2 questions. The first one is, which is the range of the iOS supported? Is backward compatible with 4.3 maybe?
Yeah, we started out with 4.3, but we have bumped it down to 5.0. I don't remember if it was C++11 or Clang. I don't remember exact reason why we bumped it to 5.0. But what you need to set the deployment target of your application to be 5.0 as the smallest number, and Otherwise, use the latest SDK, latest Xcode. Of course, that's the same message that Apple says.
Okay. And the other question is.
But I can also, because we'll support iPhone all the way down to iPhone 3GS, which is the first version with OpenGL2 support. So as long as you update to iOS 5.0, then you can, and all iPads and yeah, okay.
Okay. The other question is mostly a doubt than a question. You mentioned the mobile edition, the mobile, the new business model that you put on the market. Is this project part of that project, or will be also available outside that outside that business model?
This is a part of the Qt Mobile edition, yes.
Okay, so.
But it's also a part of the open source and enterprise edition, and like any other port.
Okay, thank you.
Yeah.
I've got two little questions. I've got an application which uses Qt Quick 1 on iOS, and there I had some trouble with Retina support, especially with font rendering, with everything that was a text edit or fonts that had some let's say some borders around them.
Yeah.
Is this problem fixed, or is it still there in Qt Quick 2?
Working with fonts is something that we are working on these days, basically. Is this a custom font, your own font?
No, that's just the standard font, but it didn't render properly on Retina devices, so I had to do some pretty ugly hacks, like increasing the whole screen size and then scaling it down. So,
but okay, the short answer is yes, we are working with fonts, and we are putting a lot of effort into making sure that if you use one font on Android, it should look approximately the same on iOS if you give it the same size and so forth.
No, the problem was that the font itself wasn't sharp on the Retina display, that it was rendered with pixels. It wasn't scaled the way it's usually scaled. So the size was the same, but it looked as if you had a non-Retina application running on a Retina display, but only for the fonts in the text edit and QM.
I guess you can't see from here, but this is a Retina display, and here the fonts are really crisp, so they are drawn correct.
We didn't have that with a normal, only text edit and text input or something. So
no, but that was an earlier version, but that's been fixed.
And another quick question: does Xcode recognize, or with the Xcode project, it didn't recognize when I changed the QML file to rebuild the resource files? Is that still
that is still a problem which we are working on these days. It will be fixed to 5.2. That's why I don't know if you saw, but I had to clean my project before I build and stuff. That's exactly why I do that now. But there's a reason why I don't mention it, is because this will be fixed before 5.2 is out. But I guess if you're going to try out the iOS port today, it's tough if you're going to use QML to wait a couple of more weeks until we have the tooling support in place before doing that.
Sorry, question. It's possible to use the Qt libraries the other way around. For instance, I could use from my Objective-C code QThread or some QNetwork, something like that, or...
So you're thinking about starting in Xcode with a native iOS application?
Yes, I do my interface in Xcode and I want to use the libraries.
Yeah, that's some of the things that we are sort of targeting a bit more for 5.3, and which we really want to put some effort into make sure we work. Yeah.
Right, thanks.
Because we know that this is probably something many iOS developers would like to do.
I wanted to ask about Retina display and images. Like on Xcode, if you have a Retina image, it is signed with the to add stuff. How is Qt supporting this way? Is it possible?
It will understand. We will check and find out if you're on Retina or not, and scale up as necessary.
Can I say automatically somehow like this image is for Retina and this is for mobile displays?
From QMake, you think, or no? Right now you have to sort of do it Apple Xcode ways. Yeah, go into Xcode and do it from there. splash screens, icons. Well, icons you can actually do from QMake, but there might be some manual plumbing there right now for finishing.
I have a question about deployment. So you told us that this application, it weighs something like 16 megabytes. Is it additional procedures to deploy it to the App Store, or something like signing or approval or something?
Yeah,
is it difficult or it's not difficult? Because I'm new here to iOS. Yes.
I mean, to be honest, yes, it's a bit tricky. I mean, you have to read a little bit, and you need certificate provisioning profiles, publishing profiles. You need to go into App Store, have a developer license. So there is a little bit of a middle there, but I mean, this is the same for all iOS application. A Qt application is no different in this respect. Once you have an application, it doesn't really matter if it's Qt or if it's native. And so I'll just recommend to just read Apple's own guidelines for doing that.
What's the story with error? If you have errors in your code, like in the QML code, how is that reported? And what's the debugging experience with this extra layer with Xcode sitting in between what you're doing in the executable?
Yeah, right now it's not very good support, I would say, if you're developing QML code and running from Xcode. So, but once the creator integration is ready, then hopefully it will improve a lot. But as it stands right now, it's not the best.
Any further questions? Just a second.
So are you planning to making Qt Creator be able to compile with Clang and fire up the simulator, for example, without the need to switch to Xcode?
Yeah, that is actually working already, but it was a little bit too immature that I wanted to use it right now. So the guy that is working on that, I think he'll probably finish something next week. But our problem is that Apple doesn't really care so much about this. So we are thinking, well, should we use private APIs for doing that? We know of a way to do it with private APIs. But this guy has also found several ways of doing it without using private APIs, but then there might be some limitations, something we can't do. But he reports that he can now open up in the simulator and also push it to the device. And so I'm pretty sure that will be ready for Qt 5.2.
Do you think there will be any problems by Apple finding out that I'm loading QML from a website?
From a website? Oh, that's a tricky question. We can't. Yeah. As long as we don't JIT compile it, it shouldn't be a problem if you just interpret it. I'm not the best person to answer that. You should probably ask Lars or Simon or go to the job booth and find them. But that's basically why we are using the V4 engine. So at least we can run QML files. But downloading them from the internet, I'm not sure.
Some more questions? Yep.
How is the performance of the V4 engine comparing to, for example, on Linux or Android? Is there any? Is it slower or faster?
I mean, the V4 engine is very new. It's like they are finishing it these days, so it's still not as fast as it's going to be, but it's still pretty fast, and especially in combination with Qt, it performs better than V8 in many areas right now. On some other areas, it's a little bit slower, but the general is that it's faster, and it's going to be even faster. I'm not sure how much I can say about this, but there are plans for really boosting this up.